Alright, so by the looks of it, this chapter is all about confidence intervals, which, well, with the t-distribution, which says that we know the sample size standard deviation, but not the population standard deviation. When you only know the sample size standard deviation, you have to use the t-distribution. So the equation looks like this. I apologize, it's hard to record and write at the same time. Alright, so they give us the mean, the standard deviation for the sample, and the sample size for part A is 34. And this is question 1 I'm going over. Alright, so when you're calculating for a t-distribution, you have to know the degrees of freedom, which is pretty easy because it's just n minus 1. So in this case, degrees of freedom is 33. Alright, so now to calculate, or to know what the value for t is, you go to that chart and you find the t value for, in this case, a 95% confidence interval for 33 degrees of freedom, and that is 2.035. I'm going to calculate this in 2 parts, just because it'll help me explain part C, or part B rather. Alright, so on the far left we have the mean, which is 19.4, plus or minus our t value, multiplied by the quantity of our standard deviation for the sample over the square root of the sample size. Alright, so this whole right side here, that is called E, which is our margin for error, which in this case, I calculate all this stuff beforehand using wolframalpha.com. It's a really nice tool to use for especially more complicated calculations. I would definitely suggest checking that out if you haven't already. But our margin for error in this part is 1.6403 approximately. So plugging that in, gives us this. So the first part asks for a upper and lower bound. So we get that just by adding and subtracting these two numbers together. So our lower bound is this, and our upper bound is this. And so that part is done. The next part, it asks what happens when they increase the sample size to 61. So pretty much every other part of the equation is the same. The things that change are these n, which is the sample size, the t also changes a little bit. Oh, let's do degrees of freedom first. So degrees of freedom is going to be 60 in this case because it's just n minus 1 for a t distribution. And so our t changes a little bit too. So t is just 2 in this case. So then our equation looks like this. So once again, the right side here is the margin of error, which is E. So we'll calculate that. And in this case is 1.204 approximately, which gives us this. So our lower bound, excuse me, is that, and our upper bound is that. It looked like you got all of that stuff, which to me is the hard parts. The question it asks was, how does changing the sample size, which is n in this case, how does increasing the sample size from 34 to 61 affect our margin for error? Now, if you remember, we calculate our margin for error as E, which is the right side of this equation. So when we calculate it this way, we can easily see that the margin for error decreases when we increase the sample size. Just as a general rule of thumb, when you increase the sample size, you will decrease the margin for error, just because that's how this part works. The higher this number is, the lower this whole right side is going to be, just because you're dividing by it. Now the next part asks you to create a 99% confidence interval, which I won't show because it looks like you did pretty well on that. The only thing you have to worry about when you change the level of confidence is to make sure you get your t-distribution value correct, because the chart can be kind of hard to go through. The question it was asking was, what happens to the margin of error when you increase the confidence level? And as a general rule of thumb, as confidence level goes up, margin for error also goes up, just for general rule of thumb. And I think that's about it for confidence intervals. I haven't looked at StatCrunch yet, but this is how you calculate all that stuff for confidence intervals. If you have any questions, let me know.